After publishing the video about the accident with Yeti Airlines Flight 691, many viewers have queried about the proximity between the condition levers and the flap lever. Is this a design fault? Did this cause the accident? Hello aviators, how are you? My name is Magnar Nordahl. I'm a captain and instructor on ATR aircraft. When reading the preliminary report after the accident with Yeti Flight 691, it appears that the commander, who was an instructor sitting in the right-hand seat, instead of moving the flap lever, moved the condition levers to feather, causing the aircraft to lose power. The accident aircraft was an ATR 72-500. When looking at the layout of the pedestal, you can see that the flap lever is located close to the condition levers. Therefore, there is a risk that the wrong control lever can be moved by mistake. Many viewers have pointed out that this design is dangerous. Why aren't the controls separated from each other? To answer this question, we have to look at the background for cockpit design and how the engine in a turboprop aircraft is controlled. And there is one more factor that is even more important. In the early days of aviation, cockpit standardization was non-existent. This is the cockpit of a Douglas DC-3, first flown in 1935. This is a DC-6, first flown in 1946. And this is the cockpit of a Tupolev Tu-134. When I saw this cockpit for the first time, I asked myself, where is the speed indicator? I couldn't find it. To my knowledge, the first aircraft that set the standard for cockpit design was the Boeing 707, first flown in 1957. The landing gear lever is on the central instrument panel. On the pedestal, you find from left to right the speed brake, the throttles, and the flaps lever. This is still standard today. Boeing 747, speed brake, thrust levers, flaps. Boeing 787, speed brake, thrust levers, flaps. Airbus is different. While the Airbus 300 and 310 had the same layout as Boeing, the Airbus 320 set a new standard. The speed brake and the flaps lever are now behind the thrust levers. ATR aircraft follow the philosophy of Boeing and early Airbus models. ATR have turboprop engines, and this requires a second control lever to control the propeller. This is called a condition lever. The engine is a Pratt & Whitney Canada 100 series. Like the turbofan, it has a gas turbine, but instead of driving a fan, it drives a propeller. This gives better fuel economy and allows to operate out of short runways. In addition to power ATR 42 and 72, the Pratt & Whitney Canada 100 engine is used to power a dozen of other aircraft types. The first was the de Havilland Canada -8, which entered service in 1984. ATR 42 followed in 1985. Those early engines had manual control of propeller RPM. The condition levers are set to max RPM for takeoff and landing. After takeoff, the condition levers are moved back to this white line, which gives 86% RPM. This is used for initial climb and for flight in icing conditions. Higher up, RPM is set to 77% to reduce the noise in the cabin. The condition lever is also used to start and stop the engine and to unfeather and feather the propeller. Later engine variants have automatic RPM control. And here the condition lever is set in auto position, and the propeller electronic control, called the PEC, takes care of the rest. Since the Dash 8 and the ATR have both engine variants, the condition levers remain in the same position. This makes it easy for pilots to swap from one variant to another. Aircraft that from the beginning were equipped with engines with PEC have a different design. On the Fokker 50, for example, the condition levers are called fuel levers, and they are placed on each side of the power levers. The Ileo IL-114 is similar. Some turboprop aircraft also have the flap lever behind the condition lever. To sum it up, the location of engine and flight controls are pretty much in the same position in all modern aircraft. Each type of lever has a distinct shape and often requires a two-step operation. The power lever is cylindrical, the condition lever is squared, the flaps lever is shaped like an airfoil, and the landing gear lever is shaped like a wheel. And this is industry standard. Back to the accident with Yeti Flight 691. According to the preliminary report, the pilot flying asked for flap 30, and pilot monitoring, who was the instructor, called back flaps 30. But the flaps did not move. Instead, did both propellers go into feather. The most likely reason is that both condition levers were moved to feather position, but this is not confirmed by the accident investigators. A feather propeller doesn't produce any thrust, even when the gas turbine is running. Therefore, the aircraft started to lose altitude and speed. Does this mean that the design of ATR is dangerous? Well, then what about Dash 8, CASA C295, Saab 340 and many other turboprop aircraft? After I posted the first video about Yeti Flight 691, I have learned that similar incidents have happened before. A pilot in a Dash 8 feathered both propellers when asked to lower the flaps. The mistake was quickly discovered, and the condition levers were moved back, and normal flight was resumed. In a similar scenario, a pilot in an ATR feathered one propeller. Again, the mistake was quickly discovered. So, this has happened before. Does that mean the cockpit design is dangerous? Before you answer the question, I want you to listen extra carefully to what I have to say. In 2016, an Airbus 320 was on approach when the captain asked for flaps 3 and then full. The first officer selected flap 0. This resulted in a serious situation with loss of lift, but the aircraft recovered. The correct lever was moved, but in the wrong direction. How can this happen? Another example. In 2020, after takeoff, the captain of an Airbus 320 called for landing gear up. Instead, the first officer extended the flaps from 1 to 3. Now, how do you explain this? The flaps lever is behind the throttle levers, and the landing gear selector is up on the instrument panel. How could this happen? More than 20 years ago, I was flying as captain in a Jetstream 31. When on approach, I called for flaps 10. Instead, my first officer selected the landing gear down. Thankfully, we were inside the speed limitations for the landing gear, so nothing more happened. After landing, I asked the first officer about this, and he replied he couldn't give any good answer. How many of you have intended to activate the turn signal but instead turned on the windshield wiper? We know the location of the lever very well, but still mistakes happen. Such mistakes are called slips. Contributing factors can be fatigue, loss of situation awareness, high workload, and lack of training and experience. Slips are related to actions and are commonly associated with attentional or perceptual failures. The person's intentions were correct, but the execution was wrong. When a slip happens, the position of the control lever doesn't really matter. As I have showed you, pilots have mistakenly moved the flaps lever in the wrong direction, or they have moved the wrong lever even when it was located far from the correct lever. For example, the flaps lever and the landing gear lever. And I am pretty sure that some Airbus pilots have mistaken the speed brake lever for the flaps lever. Without knowing what was said in the cockpit of Yeti Flight 691, we cannot tell why the propellers were feathered and why it was not discovered and corrected. The preliminary report doesn't tell this. And remember, An accident does not happen because of a single factor. So blaming the aircraft design alone for this accident is not correct. Yes, it might be a contributing factor, but there might be other factors that we are not aware of yet. Therefore, we must be patient and let the investigation team do the job. Okay, that's all for this time. You are welcome to share your thoughts in the comment section below. Just remember to show respect to others. Thank you for watching, have a wonderful day and happy landing.